Right, dear students, welcome back to another video by the Evergreen Mathematics Department. Right, so the chapter that we'll be looking at today is chapter 16, Data Handling. This is part 2 of our notes. Okay, so let's look at the first part, practice 1, page 2. Okay, so in this question, we are given that a tomato grower wants to have his tomatoes to have diameter 60 mm, and that is the ideal case, okay? But the diameter of his tomato ranging from 58 to 62 mm will also be acceptable, right? So any any diameter that is below 58 mm will be considered unacceptable, okay? So now what happens is that we are given a table, okay, a table of values, right? And they are not arranged in any specific order. Okay, so what we are supposed to do is to construct a frequency table to represent this data. Okay, so there are a few rows and 3 columns. The first column tells us the diameter of the tomato. The second column tells us the tally, and the third column tells us about the frequency. Okay, so let's look at how we can fill in this data. Okay, so one way I would suggest is for you to go through each row in the given table carefully, right, and cancelling out each number after you have considered them. So what do I mean? Okay, first of all, if you were to analyze this table, right, I would like you to just write down what are the possible diameter of the tomatoes. Right, if you were to go through them carefully, you should be able to tell me 56 to 62, right? So 56, 57, 58, 59, 60, 61, 62. Okay, so let's look at the first one. Okay, 58. So after I've considered 58, I cancel it, and under the column tally, I would write a single stroke. Right, so in general, how we would like to write our tally is given by a single stroke and in groups of 5. So 1, 2, 3, 4, and the final stroke should be written like that. Okay, so this would show us that this is a group of 5. Okay, then later we can count easily our tally, how many of such multiples of 5. Okay, so if you were to do it carefully, you realize that for tomatoes with diameter 56, okay, there are 7 of them. So you should have 1, 2, 3, 4, 1, 2, right? And doing it carefully for the rest of them, you realize that you have frequency 3 for 57, 9 for 58, 9 for 59, 8 for 60, 5 for 61, and lastly 7 for 62. Right, so I will leave you to complete the tally over here on your own. This is relatively simple. You just need to be patient and careful. Okay, so we would like to tally this total number. So what is the total number of frequency? In this case, this is 48. Okay, so what is one easy way to check if this number is correct? Okay, so you see that the table is given by 4 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So it's a 4 by 12 table. So if you multiply these two numbers, you realize that this is equal to 48. So if you have a number like 47 for the total, it means that you have not counted, right, one tomato, and you need to check your answer. So in this case, right, the total number of tomatoes he grew is, so total number is simply equals to 48. Okay, next, percentage of tomatoes rejected. So like what I mentioned earlier, right, 58 mm to 62 mm is acceptable. 60 mm is the ideal case, right? Anything lesser than 58 is unacceptable. So we should be looking at the diameter of the tomatoes, which are equals to 56 and 57, right? So in total, percentage or required percentage is simply 7 plus 3 over the total number multiplied by 100. Okay, and press this out, you should get 25 over 6%. Right, if you would press your calculator and give me to 3SF, Okay, this is not acceptable. Okay, because the answer is exact, so I would expect you to leave your answers in exact form. Okay, so this is the answers for the first part of these notes. Right, so let's look at example 1 on page 3. Now, example 1 is looking at a group frequency table. Okay, so just take some time to observe the differences between the data, right, in the first question over here and this question over here. What do you realize? You realize that the data here, right, have a higher degree of accuracy because they are to 1 decimal place. Okay, so what happens now? You realize that it will be difficult for us to list every single data, right, because of the wide range. So what we are going to do is to use something called class intervals, right, to group this data. Okay, so what is a class interval? An example of a class interval is like that, right? A range which is given by x between 0 and 1 inclusive. Right, so we can actually write a few class intervals that cover the data set that is provided. Okay, so let's look at the first class interval, right? So in this case, right, the context of the question is that we are given time taken in hours by each of the 30 students to finish their homework. Okay, so the timing here that we see are the time taken to complete homework. Okay, so let's look at each individual data and tally them. So for the first one, 2.5, which class interval should it lie in? 1, 2, 3, or 4? Right, you should be able to clearly see that 2.5 lies in the third class interval. Okay, next, how about numbers like 2.0? Should it be in 2 or 3? Okay, so in order to answer this question, you should be very careful in reading the inequality, right? This equal sign for lesser than equals means that 2 is included. So for the case of 2.0, we should be choosing the second class interval. Okay, so I would like you to spend some time to pause this video and fill in this table on your own carefully before you check your answers with me. Okay, so you will realize that for the first class interval, the frequency is 7. Second class interval, frequency 3, followed by 9 and 9. Oh, okay, so there's a mistake, sorry. So let me repeat myself. The first class interval, you should get 4, 9, 12, followed by 5. Okay, and the total number will be 30. Okay, check your answers. So in this case for 12, you should have something like that. 5, 5, 2. Okay. So for part B, they want you to find the percentage of students who took more than 3 hours to finish their homework. So more than 3 hours, we are looking at the fourth class interval over here. Right, so how many of such students do we have? Right, it's very clear. The frequency tells us that there are 5 of such students. So required percentage is simply 5 over 30 multiplied by 100%. And that would give us 16,203%. Okay, and we are done. Okay, so example 2, you want to represent your data in the frequency table with class intervals of such. Okay, so the context of the question now is that we are looking at the price of 24 books. Okay, so how do you do this question? Okay, it's exactly the same as this. I would just like you to copy this table over here. Okay, and for the heading, we should be changing time to price. Okay, in dollars. Okay, and based on this class interval, arrange the data carefully, and you should be able to get, okay, what you require. Okay, and finally for part B, I'll leave it to you to do it on your own. I'm going to give you the final answer. Check that you have 45/5/6%. Okay, and the rest of the questions, right, try it on your own and do it on writing paper neatly and carefully.